Problem 3. It wants us to basically solve this problem. Now we could use a quadratic formula, but we don't want to do that here. We want to say, hey, can we factor this? Now you could bust B, but I notice, hey, for a 30 there's a 10 and a 3, and for 3 there's 3 times 1. That 3 and 3 together would make a 9, and the 10 and 1 would make a 10, and the difference would be 1. So I can sort of see that I'm thinking this is going to be a 10x and then 3x here. So that creates my 30x squared. Now 1 goes here, 3 goes here. Nah, I'm looking at a 3 here, 1 here. 3 times 1 to give me the 3. And I can see, hey, that's going to be 9, that's going to be 10. Now to create a subtraction, I need the 10x to be larger. So I put the subtraction here, the addition here. So I see a 9x minus 10x is going to give me that. So I see that it factors down into that, and that equals 0. Now again, you might have to play with that to get that, but I can see that pretty quickly, and that's what helps me, playing with these all the time. Now, let's solve this. We have this times this equals 0. So one of these guys has to come out to be a 0, doesn't it? So all I need to do is set 10x plus 3 equal to 0 and set that equal to 0. Now either the solution is this or it's this. It's one of these two. We don't know which, but either one of these will work. So what we do is we solve it. Subtract 3, subtract 3. 10x is a negative 3. Divide by 10, you're going to get x is negative 3/10. There's one solution. Add 1. 3x is equal to 1. Divide by 3, you're going to get 1/3 is the other. So it's either negative 3/10 or 1/3. This is much faster in this situation than doing the Pythagorean theorem. Sorry about that. The quadratic formula. And notice that if you sat here, what we're doing is we figure that if you plug in negative 3/10 into that x and into that x, that's what's going to make it come out to be 0. So here are your two solutions. You need them both. It is an or that is between them, not an and. Problem 3, there you have it.